Welcome back to our discussion on logarithms. We're going to be looking at 3.2 today, but I'm going to start by going back to our definition of logarithm from the notes. Again, that is our first question on the next test. What is a logarithm? And you're going to be asked to tell me what is a logarithm. You're going to say a logarithm is the exponent that turns its base into its argument. I might ask you to cite an example. Like log base 5 of 7 is the exponent that turns 5 into 7. Or for instance, log base 2 of 8 is the exponent that turns 2 into 8. What is the exponent that turns 2 into 8? Oh, 3. 2 to the third equals 8. Log base 2 of 8 is just 3. So with that, let's jump on to our first page of 3.2. And here we're going to use a calculator. And so I'm just going to find log base 10 of 4/5. So I can go to my calculator and I can hit alpha window log base 10 of 4/5, and they ask us to round to 3 decimal places, so that is approximately negative 0.097. Now, most definitely worth noting, this log base 10, this is called common log, and it's used quite a bit, maybe somewhat surprisingly at this time. Log 10, the one that's probably used most in your logarithmic history, is used much less often than log base E or ln in calculus. But anyway, definitely worth noting, this is actually could just be called plain old log x. If you don't have a base there, it's assumed to be 10, so we truthfully could have done this way. Just hit plain old log. You'll hear me refer to it as plain old log all the time. 4/5. Okay, so number 30. We just want to find 1.9 times log base 10, or log, of 4.3. This is the exponent that turns 10 into 4.3. So 1.9 plain old log 4.3, and we get approximately 1.204. Well, that's pretty simple. Okay, 31 through 36. Now, logarithmic functions. The graph of logarithmic functions, which we're going to be talking about soon, like for instance, y equals log base 2 of x, they look like that. We can't put 0 in there. This is an asymptote right here because there is no exponent that will turn 2 into 0. But there's more discussion on that coming up. But the important thing to note is these functions are 1-to-1. And therefore, log base 5 of 5 equals log base 5 of, there is no other option than this. Well, that makes that pretty darn easy. Take a look at 36. Log base 4 of 4 to the third equals log base 4 of x. X must equal 4 to the third. X equals 4 to the third, 64. Okay. Now, 34, a little bit different. This one's going to rely heavily on the definition of a log. Forget about x for a minute. This thing right here is the exponent that turns 3 into 3 to the negative 5th. Let that soak in for a second. This is the exponent that turns 3 into 3 to the 5th. What is the exponent? Because that's what this thing is. This whole thing is the exponent that turns 3 into 3 to the negative 5th. What could this whole thing possibly be other than negative 5? Negative 5 is the exponent. Negative 5 is this whole thing, so x is negative 5. Negative 5 is the exponent that turns 3 into 3 to the negative fifth. And that, for some of you, you're going to have to review that and review that and review that. You'll see 33 is very similar. Don't go through this and just say, oh well, I guess I just call it 2 for 33. Understand. Instead of reading this log base 4 of 4 to the second, ask yourself, what is the exponent that turns 4 into 4 to the second? 4 to the what equals 4 to the second? Oh, that whole thing's 2. All right. And now we're actually going to use the property of the logarithms to simplify the expression here. I'm going to rewrite this one just because it's very, very tiny and tough to see. 6 log base 6 of 36x. Now, once you're really good with logarithms and really have a good understanding of them, this is almost insultingly easy. I had an example similar to this when we talked about logarithms on the very front page of the first video in this section. If I asked you for 59 times 17 divided by 17, would you do all the work out and enter it in your calculator? 59 times 17 divided by 17 is just 59. Let's just take a look at this right up here. Let's just focus in on log base 6 of 36 for a second. Definition log. This is the exponent that would turn 6 into 36. That's what our definition of log says. This thing is the exponent that would turn 6 into 36. Oops, there's an x here. Into 36x. What is the exponent that turns 6 into 36x? This thing is. Well, take a look. That's this thing's whole purpose. If this was 6 times log base 7, I have no idea how to do this. Or I might have no idea how to do it based on what we know right now. If this was 6 log base 5 of 36x, I don't know. But this thing right here, which is an exponent on 6, listen to this, this thing right here, which is an exponent on 6, is the exponent that would turn 6 into 36x. This thing is right there. So it does turn it into 36x. And that one is a bit mysterious at times. You're going to have to see some of that. You're going to need to ask questions on it. I've worked probably harder at trying to explain that one concept, and perhaps it's just something I don't have my head around really well explaining it. I really understand it well, but this thing is an exponent. And not only is this thing an exponent in this problem, it is specifically an exponent that's whole life purpose is to turn a 6 into 36x. And it has found a 6 to turn it into a 36x. All right. Number 40. This right here, I've got 1/4 times the exponent that turns 4 into 16. What is the exponent that turns 4 into 16? Well, 2 is. So this whole thing is just 2. 2/4 or 1/2. So quick page once it's really understood, but of all the pages we've had so far this year, we're getting into some that I think, you know what, even though they can be done quick, they're short, there's probably going to be some questions. So don't avoid understanding this. Don't just try to, oh, well, he did this. I can go through that and memorize it. That will fail you down the road. Well, let me know how I can help.